Hello students, last class we seen about the four-stroke petrol engine working principles. In this class we will be discussing about the working of four-stroke diesel engine. First we will see the significant constructional features and the major difference between the four-stroke diesel engine and four-stroke petrol engine. The only difference is the injector. The injector which is mounted on the cylinder head instead replacing the spark plug. That is the main difference between a diesel engine and a petrol engine. If you compare a petrol engine and diesel engine, there are few significant points which we can talk upon, which is first thing is the cycle. Petrol engine works on Otto cycle and diesel engine diesel cycle. This is a constant pressure cycle and diesel engine is working on constant volume cycle. Petrol engine fuel air mixture is admitted during the suction stroke through a carburetor, or now it is multi-fuel injection. Air fuel mixture is admitted in suction stroke, but in the case of diesel engine only air is allowed inside the combustion chamber. And in petrol engine, a spark plug is used to ignite the air fuel mixture. But in the case of diesel engine, you don't need any spark ignition. Instead of that, the air fuel mixture will be combusted by the high compression ratio of the air. And petrol engine operates on very low compression ratio and diesel engine operates on higher compression ratio. This is the reason why the heavy vehicles are running on diesel. Weight per power ratio is higher for diesel engine. The petrol engine has very low engine efficiency and diesel engine has higher efficiency in terms of amount of calorific value given to the engine and the power produced. Based on that, the engine efficiency is calculated. And petrol engine consumes more fuel compared with the diesel engine because air fuel mixture is supplied for the suction stroke. In the case of diesel, you supply only air and a metered quantity of fuel is injected in the case of diesel engine. Then the petrol engine advantage, which is the significant, is lower engine vibration. You get a smoother ride on petrol engines where you get somewhat higher vibrations in diesel engine due to higher compression ratio. And petrol engine requires higher running cost, maintenance cost is higher, and light duty application. Diesel engine used in low running cost because of the fuel cost. And now we will come to the features, operational working principles of the four-stroke combustion, compression ignition engine cycle. Here also you have four stroke, that is intake stroke, suction stroke or compression stroke, combustion or power stroke, then exhaust stroke. You can see instead of spark plug you have this fuel injector placed on the cylinder head. We will see one by one. First we will see the intake stroke. In intake stroke, already I said that this is the top dead center and this one is the bottom dead center. The distance between these two are called a stroke. Now you can see the inlet valve is opened and the air is coming inside as the piston moves from top dead center to bottom dead center. Due to the negative pressure created inside the cylinder, the air will be sucked in. This is the first stroke. You please remind that last video also, where you got air fuel mixture is coming inside. The second stroke is compression stroke. you can see both the valves are closed. The piston moves from bottom dead center to top dead center. So the air is got compressed. Please remember, the compression ratio will vary from 10 to 20. Normally, if it is a single cylinder 4-stroke diesel engine which is used in our labs, will have 12.6 compression ratio. And the next stroke is an important stroke, which is a power stroke. As in the case of petrol engine, we know that air fuel mixture is compressed and a spark is produced. But in this case, both the valves are closed. As in the case of petrol, here also the diesel engine has two valves, inlet valve and exhaust valve. Two valves are closed, and when this compression stroke going to be completed, when it attains top dead center, a metered quantity of fuel is injected into that highly compressed air. So the temperature and pressure of that air will be very high, and it acts as a positive atmosphere or supporting atmosphere for the injected fuel. So the diesel gets auto ignited and the burning takes place. Due to the power produced inside this combustion chamber, there is no other go. The pressure waves has to be dissipated only on the piston, and the piston moves down. And this is the only stroke where you get power, that is the heat power, which is converted into mechanical energy. As it reciprocates, again you have a connecting rod and a crank, and these joints will convert this reciprocating motion into rotary motion, and that will be transmitted to the gear drive. Next, the last stroke is exhaust stroke. As we know that after the combustion you will have exhaust products, exhaust gas, carbon dioxide, carbon monoxide, sulfur dioxide, nitrous oxide, unburned hydrocarbon. All these things will be present inside this cylinder that has to be pushed out. Now the exhaust valve opens and the piston moves from bottom dead center to top dead center, thereby pushing out the exhaust gas which is present inside the cylinder. So we can recap these 4 operations. First one is suction stroke, where the air is coming in. Second one is the compression stroke, where the air get compressed. When it attains TDC, you get a metered quantity of fuel injected inside the compressed air and it get ignited, and the power is produced. The piston moves down. At the end of the stroke, the 4th stroke, the piston pushes out the gases, exhaust gases outside the cylinder. So this is the working principle of 4-stroke diesel engine. Please you can compare the diesel engine operation and petrol engine operation, and you can compare the 2-stroke engine operation and 4-stroke engine operation, which will be covered in the next video. Okay, thank you.